Welcome to Hartman Math. This is lesson 4.3, Radical Expressions and Rational Exponents, Part 2. We've taken a look at the relationship between a base that's raised to a rational exponent, just meaning an exponent that's a fraction, and the equivalent radical expression, also known as root. So again, the denominator is the index. It tells us which root to take. The exponent, the power, the numerator being the power, can be inside, it can be outside. Either is fine. So we're going to use that to simplify each expression. We're not going to use any decimals. We're going to say 8 to the power of 1/3 looks like this. Let's rewrite it like this. It's saying take the cube root of 8 and raise that to the first power. And if it's raised to the first power, we don't need to write that. And we know, according to our list of cubes, that the cube root of 8 is just going to be 2. Let's take a look at this one. 81 to the 3/2 power. Again, let's rewrite it as a radical. As a root, we're going to take the denominator is the index. So square root, again, if it's a second root, we don't need to write the 2. You can if you want to, but we don't need to write that. Square root 81 and then raise to the 3rd power. It's going to be easier if we take the root first, meaning that the power is outside of the parentheses. What's the square root of 81? We know that to be 9. 9 to the 3rd power. Might need calculator help on that. You can type that in, you get 729. 16 to the negative 1/4 is going to go back to lesson 4.1, our exponent properties. The negative exponent is going to indicate reciprocals. So the first thing we're going to do before we even get to the roots is to rewrite this as 1 over 16 to the 1/4 power. Now we can use roots. 1 over, don't lose that fraction, 1 over the 4th root of 16. Not the square root of 16. I know the square root of 16 is 4, but what's the 4th root of 16? Meaning what number to the 4th power makes 16? That's 2. So our answer is 1 over 2, still a fraction. Some more here, 64 to the 2/3 power. It's in parentheses, but really that doesn't change anything about it. So we are going to do the cube root of 64, raise that to the 2nd power. Cube root of 64 is 4. So we're talking about 4 to the 2nd power. That means 16. So we've got a negative and a negative exponent. Let's not worry about this. Let's worry about this. Negative exponent, just like we saw in the previous slide, means reciprocal. So 1 over this to the positive 3/2. And when we're dividing a positive by a negative, that negative could just come out at any time. We'll rewrite this as a root. Denominator tells you which root to take. We're going to take the 2nd root, that means square root. Don't need to write the index. Square root of 25, we'll raise that to the 3rd power. What's square root of 25? That's 5. So 1 over negative 5 cubed is 125. So at any time that negative can come out in front, 1 over 125. Number 3, cube root negative 1,000. Now, if this was a square root problem, we'd have issues. We're not in the real number system. We're not allowed to take square roots or other even roots of negative numbers, but it's okay for odd roots. We're saying what number times itself again gives us an answer of negative 1,000. Or another way of saying that, what number to the 3rd power is negative 1,000? And it's just negative 10. So it turns out the cube root, or any odd root of a negative, will be a negative answer. A few more and then we'll be done here. 27 to the 2/3 power. We've seen problems like this, so this shouldn't be hard. Denominator tells you which root to take. We're going to take the cube root of 27. We're going to raise that to the second power. The cube root of 27 is 3. So 3 squared is 9, and that's our answer. How does that relate to this one? When it's a negative exponent, we start with the negative exponent property. 1 over 27 to the 2/3. So we kind of already know what 27 to the 2/3 comes out to be, but as practice, we could rewrite it. Ooh, a little typo, that should be a 2 right there. And then we're talking about 3 to the second power. So 1 over 9. So all that's different here, reciprocals, positive power, negative power, they end up being reciprocals. What if it's negative? It doesn't have anything to do with reciprocals. We would just start with cube root of negative 27. We just saw that when you take an odd root, like a cube root of a negative number, you just get a negative number. So this is, well, if that was 3, this is going to be negative 3 to the second power. But when you raise a negative to an even power, like squaring it, we're going to get a positive. We get positive 9. And that's it for today. I'll see you next time.